Okay, so it asks us to draw two different parabolas that have x-intercepts of 0, 0, and 8, 0. I've drawn that here. And I've drawn two different ones. One that has a vertex of 4, comma 3, and another one that has a vertex of 4, comma negative 2. They have to have a vertex of 4, comma something. The axis of symmetry is x equals 4. So the answer at the end is how many of these are there? The answer is there's an infinite number. You can make the vertex anything along the axis of symmetry here. But let's find out the equations for these two. Well, first of all, since they have x-intercepts of 0 and 8, I know the equation has to have this form. I'm going to modify this a little bit in a minute. But when the equation is factored, it has to be x times x minus 8, because the x-intercepts have to be 0, which would, like when you substitute 0 in for y, either this part has to be 0 or this part has to be 0, and the x-intercept should be then 0 or 8. The only difference here that's going to affect the width and therefore the vertex is this multiplier outside here, a. So we're going to put that on both of these. It's some factor a times x minus 8. So we just need to figure out what the a value is. So we're going to take the vertex 4, 3, put 4 in for x in both spots and 3 in for y. Then we're going to solve down here. We have 4 minus 8, negative 4 times 4 is negative 16, and I divide both sides by negative 16 to get that the a value must be negative 3/16. So I put that in for the a value, and here's the equation for this one. Notice it's negative here, which means it opens down. So it checks out. Over here I do the exact same thing. I put in the vertex 4, comma negative 2, so I put in 4 for x and negative 2 for y, solve, and I get that the a value is 1/8. And again, here's the equation there with the a value substituted in. Again, anything of this form, you can put in any different thing for a, and therefore there's an infinite number of possibilities.